Here's the key for TST2A fall of 22. There's the history. No blue on that. There's never blue on history. Here's how the top, the top 20. This is top 22. The top, the median score was 145 out of 150, which is crazy high. Anyway, so there's the tops. If you're looking at pecking order for the top 22. There's no blue on this one, and it's kind of, we've been doing this one for a while, and it was, just slope data, which is derivatives in calculus, but this is fairly easy. You should have got a bonus point if you colored in and you didn't have to do this, that's why it's bonus, colored in the right triangles on top. Remember that negative slopes get an upside down right triangle, positive slopes get a right side up right triangle. So bonus there. The red shows where all the points were taken. All right, so there you go. And now 2 and 3 are blue, so let's look at those. I'll blow this up a little bit so you can see it. You had to color those in. That's because it says right here, you must color in, so it's 3 points. And then the rubric there, 5, 5, 6, is for the points on those. Once again, you did not need to, sorry about that, you did not need to color in the right triangles on the top graph. I gave you a bonus if you did. That's extra work. And then for the integrals, these are very simple integrals, but it does give you the basics of the language of integration. So on where people did really well on this, better than last year and the year before. But where you made your omissions was not putting units maybe, or getting the units wrong. If you said meters per second, that's sort of a standard, and it's only 1 point off. That's all you did. If you forgot to put, you got to put minutes, or this happens to be minutes. It's whatever that axis is. But you got to put minutes or seconds or hours, whatever that is. And first semester, the horizontal axis is pretty much always time in kinematics. Anyway, so you had to put units there. And this little dt means this is all with respect to time. And whatever this axis is, if this were x, you would have said dx. If this were y, you would have said dy. See what I'm saying? So that's just telling you I have a function with respect to, in this case, time. All right, so those are all blue, half credit back, and you round up. Now this one's blue, although I consider not even making it blue, and that'd be the first for a unit analysis. But 18 people can benefit pretty good from it being blue. So, man, 35.414 is a crazy score. Really good. I expect that kind of score. 30 means 35 students understood it really well and maybe made some dumb little mistake, but understood it. 4 are close, and 14 still are struggling, but I'll work with those 14. All right, so one of the main, this came right out of the practice problems, and the main, if you can get past the givens, so these givens here, that was the hardest part, was you had to manipulate the variables and, come up with delta theta r and then divide it by v. Other than that, I think you're getting the conversion idea down pretty good. Some of you are still saying there's 1,000 meters in a millimeter, a million seconds in a microsecond. You're getting that flipped. But you'll get over that. I feel pretty good, really good about it, actually. Okay. Number 5, that is blue. Finger dance stuff. Here's the choreography. Good grief. Here's the choreography. And then up here is telling you where your fingers go. You start at what it tells you to start at 70 centimeters. You drop back 30, okay, at a certain speed. Then you slow down. This isn't telling you speed though up here. This tells you speed down here. But this tells you your position change. And so in the next 3 seconds, you slow down a little bit. In the first 5 seconds, you get all the way to 40. And then in the next 3 seconds, you drop down to 28. So you're kind of this is showing accumulation. Then you turn around, blue represents going forward, okay, in first quadrant on the V versus T. So you turn around, you go 28 back this way. That puts you at, I don't know, where is it? 50 something. And then you turn around again and go 40 all the way back to like 16 or something. You end up. This 5C over here is the first part's easy. It says, what's the velocity at 13 seconds? Well, I go at 13 seconds, as I can see my velocity is 4 centimeters per second. But then the hard part is find the position. That means I got to count up all these boxes. Well, when I count the boxes, I get 24, and some people said 24 there, but they forgot that this is a 2-to-1 ratio. So each box represents 2 centimeters. So it's actually 48 by the time you get to the 13th second. Okay. Here's the trio. You do the Stegosaurus tail. It shows the points there. Hey, by the way, on those couple of those previous problems, I included the video key from last year. So if there's some discrepancy, that's the reason, slight discrepancy. But it does show the correct way and the key to do it. This one, it's the same routine. A lot of you missed 6A because you forgot to do the secant line and then find that slope, and that can easily be fixed. Also, some of you on this one, you didn't realize that was 4. There's a 4. You got to be careful on your spacing, and some of you thought it was 5, I think, and that made you think this last one was 6. I took off a point or two for that. So basically, you do the Stegosaurus tail, finds how your slopes is they're all divided by 1 because they're all conveniently 1 second. Find out how much your delta x's are increasing, and then you plug it in. You put those in this table over here. You draw your steps, and that's those orange steps. You collapse each step, as we talked about today in class. You collapse each step down to a dot because in the mid-time position, tangent and secant are the same. And then you do a best fit line through those purple dots here. And then just find the slope of that line. That's your acceleration.